Mhm.
Hello everyone. My name is Rakshit Shah and I am a volunteer at IEEE Bombay Section Student Activities Committee and your host for today. I welcome you all to week 3 of Xtreme Overflow known as the Voyager. To go ahead in this journey with us, we will need to equip ourselves with knowledge of binary search and divide and conquer. And for that, we have our today's speaker, Mradul Bhatnagar. Mradul is a data science intern at Fresh Gravity and has been ranked 179 globally in the Google Kickstart Round C. He has also been rated 2111 masters on CodeForces. So let's welcome him on board and hope to have a great session. Over to you, Mradul.
Hi guys. So as Rakshit said, thank you so much, Rakshit. So I'll be telling you a little about binary search today. I have a competitive background. I've been doing competitive programming for about 3 years now, and I'm 6-star on Code Chef and a master on Code Forces. So I do know a little about binary search and divide and conquer, and that's what I'm going to try to explain to you today. And do communicate in the comment section if there's any doubts that you guys have, and let's hope I'm able to teach you something new. So I'll be sharing my screen now, and we'll take it from there, right? Can somebody confirm if my screen is visible? Is my screen visible?
Yes, yes, your screen is visible, Mradul.
Okay, great. Then I will start, right? So, what is basically searching actually? So searching is basically trying to find something, right? And the obvious way of doing it is so let's say you have this as an array and you're trying to find something. Let's say there are a lot of numbers here. There's 3, 7, 10, 11, 14, whatever, and you're trying to find out where is what. So you could start from here. You can look for this guy. Are you, let's say we're looking for 14. So you look at this guy. Are you 14? You say no. Then you say this guy 14. No, no, no. Oh yeah, that's me, right? So that's how it works. So what I'm trying to say is that you need to start from one end, or you need to go on to the other end, and this way you are able to find the element that you're looking for in O of n. That's order of n time. That means you need to go through the entire thing at least once to finally get the answer. Now, what we'll be trying to do today is to explore one of the interesting concepts, the fact that this thing is increasing in nature. So, once something is increasing in nature or decreasing in nature, we call this thing as, I think we can type over here. So, we can call this thing as monotonic function. Now, what does monotonic mean? It means, it ideally means that the derivative is only one way. That's not the point. The I like to say that it either increases, stays equal, or it either decreases or stays equal. That means there is no goes up and goes down in it, right? So we want to exploit this fact. This is a nice fact. So here's how we do it. Okay. So uh, are we having someone who's checking in case there's any doubts?
Yes, we are looking at the comments, and if we have any questions, we'll post it up.
Sure, sure. Okay. So now let's say that this is a number line. Okay. This is numbers 1 2 dot 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 dot, say 20. Okay. Now you want to find out where is the number 70. So the way this works is, so I take this as the starting point, this is the ending point. I look for say somewhere in the middle, and I ask myself, what are you? And then this guy will say that I am 10. So now when this guy says I'm 10, and they're in sorted order increasingly, so 14, where will 14 be? So it can't be this side because 14 is less than that. So it will obviously be this side. So initially we were looking at a size of size 20. Now we can say that this area it does not have it, because 10 say the 14 is obviously greater than 10. So this will be 10 say bigger. So obviously it's not in this side. So now I can change my looking embed to here, and we can, as good as anything, we can just forget this, right? So now we have the same problem on our hands. Where is 14? Except the size is now, initially size was n. Let's say the initially size was x. Now the problem has moved to a size of x by 2, right? So this is what has happened. So nothing has changed in the problem. Still, we don't know where 14 is, but now we have reduced the size to x by 2. Now let's apply some basic math over here. Okay. So we'll keep on dividing by 2 till we only have one element left, because if there's only one element left, that will be the correct element that we are looking for. So initially we'll have x, then we'll divide this by 2, we'll have x by 2, we'll divide it by 2, we'll have x by 4, x by 8, and so on. And eventually you'll run out of, you can say, you'll run out of x. So the mathematical number for how many times this can happen is equal to log to the base 2 of x, and that is the asymptotic complexity uh, of of binary search. So it is O of log to the base x. Now, why is this a great advantage over that? So now let's assume you have 1,224 numbers, which is basically nothing but 2 to the power of 10. Right? Now you have 1,024 numbers is 2 to the power. If you do a linear search, you need to do it 1,000 times, and if you do a binary search over log of this thing, so you just need to do it 10 searches. So the 24 is much greater than 10. So obviously binary search is the way to go. So this is what the basic concept of binary search is, and that is the most elementary, or you can say rudimentary way binary search is used. Now let us try and understand, is there any doubts so far? It's pretty, or you can maybe write in the comment section, it's pretty clear.
No, no, as of now, we don't have any doubts.
Okay, so now I would request everybody, if you could just read this question. We'll try to solve this question on our hand, and then probably write some code also for this. So everybody, once you have uh, seen it, maybe then you can just make it a point. has everybody read it? Maybe somebody can update me on that.
I think we should wait for a minute.
Okay.
Let them read properly. I think we should go ahead. As of now, we don't have any response. Yeah, so we have Omkar Tawate saying yes, done.
So now let's try and understand the question. Okay. So happening. So basically, what the situation is, so we'll just focus on this part which I'm dealing with. I'll increase the size a little bit. Yeah. So we have n stalls and c cows, right? And so we have to put the c cows, the cows in the stalls, such that the minimum distance between them is maximized. So one approach could be a brute force way, right? So what would be the brute force approach? You just find out all possible ways to put C cows in the n stall. So that will be n choose C. So your complexity will be O of n choose C. It will be a big number. It will be the order of O of n factorial, right? Which is huge as compared to what we'll try to find. The second approach is a binary search approach, which I'll be discussing. And it is a very interesting approach which has widespread applications. So we'll try to understand what is the scene over here, right? So here, so now let's assume that this is one stall that we have. Let's say one. So there are two. This is we have stalls at position one, two. So let's assume it here only, right? So we have stalls at position one. Little tricky this way, but then yeah, we have to. And then we have one at. I'll just put this first, right? So we have 1, 2, 4, 8, and 9, right? 1, 2, 4, 8, and 9. Okay. So now what I'm trying to do is I am trying to. Now I will say I will ask myself, can the answer be 1? So what do you mean by can the answer be 1? So pehla I kept the first one, the first cow at 1, and then I asked that the next, since the answer should be 1, the next cow should be at 1 plus 1 or greater. So that means the next cow should be at 2. So now you put the second cow at 2, and then the next cow should be at 2 plus 1, should be at greater than 2 plus 1. So it should be at greater than 3. should be at greater than 3. So now where do we put it greater than 3? We put it at 4, right? So now when you keep them in this range, I can keep one cow at 1, the other cow at 2, and the third cow at 4. Okay, and the answer would be 1. So 1 is possible. Now I ask myself, can the answer be 2? So I
Sorry to
ask,
interrupt, Mradul.
yeah, go ahead.
I think there was some network issue, so they were not able to hear you. So can you just repeat yourself a bit?
From where exactly?
Uh, I guess I don't know where they want you to repeat from. If you just can go a bit back.
So I start from let's say here. Okay. So now we have five. What was this? Yeah, we have five stalls. Okay, we have five stalls at 1, 2, 4, 8, 9, which is corresponding to the staircase 9. Okay. Question: Can some question? Can the minimum distance of them? So like check the first cow at second 1 plus 1 or greater than that. Second cow एक मैंने इधर रख लिया. I kept one cow here. Then I kept one cow here because 1 plus 1. Then 2 say at least one distance away, so I kept it at 4. So that means answer 1 is possible. Now I ask myself another question. Can the answer be 2? So, so like I put the first cow at 1. I'll just need to copy a lot of it. I kept the first cow at 1, and now the next cow will be needing to be at 3 or greater. So the next cow can't be at 2. The next cow will be at 3 or greater, which means at 4. So the next cow is at 4. Now once I am at 4, once I am at 4. Now the next cow needs to be at greater than 4 plus 2. Matlab 6 should be at greater than 6, which means should be at 8. So I put another cow here at 8, and again 3 cows are there, and the distance between them is at least 2. So GG. Now extrapolating this to a large extent, I ask myself, can the answer be say 10? Okay, can the answer be 10? So now I ask again myself this question. I kept the first cow at 1, and then I have to keep the next cow at 1 plus 10. So which means I need to keep the next cow at 1 plus 10, which means should be greater than 11. But there exists nothing greater than 11. Right? So what happened is that we reached the end of the stalls without successfully placing C cows, right? So that means answer so that means answer 10 is not possible, correct? Now the question is, our answer has to be between 1 and 10. So now is where the monotonic part comes in. I'll put it in bold actually. Monotonic part, right? Monotonic part, right? So the fact about this monotonic part is that if answer possible is 7, so then obvious है कि the also 1, 2, 3 dot 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 up to 6 is also possible, because if there can be a distance of 7 between them, so 6 should also be possible, right? So that's what I'm trying to convey, that it's a monotonic function. Agar if the bigger one is possible, then all the smaller ones are possible as well. So we are going to exploit this fact, right? How are you going to exploit this fact? So again, ये scene है. So this is okay. Find where this point is, right? Where is this point? कि इसके आगे it is not possible. Before this, it is possible. So the is simple again, that number line thing. So numbers will be 1, 2, up to very big number 10 to the power 9. And I ask myself in the middle, if yes, if this is yes, so that means everything over here is yes. And if everything over here is a yes, that means this part is where the point, I can say the inflection point, or the point where there's a problem will start to. So we need to find this point over here. So our searching space is reduced by half. Okay. Now one more question might arise in your mind, that how do you check for this given point? We'll discuss that now. So now we have decided. So now the next part is we need to find that if a distance x is possible. X is possible. Okay. So how do you do it is, so first step one would be you place the first cow on the first position, right? And now you look key, and now so now let's say the first position is D1, okay? So D2 needs to be at greater than equal to D1 plus K, right? K, so D1 plus X, which is the distance you're looking for. So then you look for the smallest number greater than X available to us, right? Available to us or in the stalls, and that becomes our D2. Now we repeat this process continuously until we reach D of C, where C equal to the number of cows. If we are unable to reach it, then obviously answer is not possible. If we are able to reach it, then the answer is possible, and that will be the answer which you are finding. Okay. So I would like to try a little bit. So let's say we'll run it for this case only. Okay. 489. So I hope this works, keeps on working. So there's 1, 2, 4, 8, 9. Okay. Obviously the maximum distance is 8, so the cannot be greater than 10. Cannot be greater than 8, but I'll just take 8. Okay. So the answer cannot be greater than 8, right? Okay. There's 8 here. So पहले क्या you test number 4 first, right? So you will test if number 4 is possible. So is number 4 possible? We put 1 over here. अब अगला should be at 1 plus 4 or greater than that. So 1 plus 4 is 5. So 1 plus 4 is 5. 1 plus 4 is 5, right? So 1 plus 4, 5. So should be greater than this over here, right? So if we get the second point over here, so it needs to be at 8. And then the that should be the one, it should be even greater than this. So that is not possible. So 4 to possible nahi hai distance, because 1 plus 4, 5, and then we have to keep it at 8, and 8 plus 4 is out of the bounds. So then the region decreases to 1 to 4, right? So now from 1 to 4, you need to check at 2, because 1 plus 4 by 3, 5 divided by 2 का floor. Now for 2 you check, तो 1 पे 1 डाला, फिर 1 के बाद 3 से just get 4 पे डाला, 8 पे डाला. This way, this answer is possible. So then you check for 3. So 1 पे डाला, then 4 पे डाला, 1 plus 3, 4. And then you put it at 8. So that means 3 is the correct answer, because 3 से बड़ा वाला was not possible and 3 से छोटा वाला was possible, right? So this way 3 is the answer. Are there any doubts?
No doubts. Go ahead.
Right. Okay, so this is about binary search, and this was largely of what I wanted to convey today. Now I want to ask the audience whether they would like to know the code, or this is the end of the session. Otherwise, we just wanted to understand whether should I be coding it for you guys if you want to see how we really code it, or is it just the explanation part. So maybe in the comment section you can let us know if you want to get the code. So I'll try to code it with you guys. Otherwise, just bring it to an end. Couple of minutes, and then we'll take some questions if there are any. Do we have anything, Akshay?
No, Mradul, we don't have anything. Yes, sir, we will like to see the code. Omkar Tavate.
You would like to see? Okay, then I'll try to give in a quick brief of how do you put this. So there are 2 parts. Okay, so we'll just work on this page. Low will be the lowest possible distance. High will be 299, which is the greatest possible distance. And then there'll be a middle and there'll be answer. Right? But if you coding, you go like this. Because you type high is greater than equal to low because otherwise the binary is not possible. Middle to high plus low by 2, right? So it will be equal to high plus low, where in the problem we're checking, right? The midpoint. Now what we do is we check if mid is possible. I'll define a function check about later. If mid is possible, if check mid equal to true, if check mid equal to true, I mean this much is possible. So that means answer because it's possible and low will be plus one because we need to find our range goes ahead of this. And if this is not possible, then we'll just change high equal to mid minus one, right? Okay. Now this is the part. Now the question is how do we check, as I was discussing. There is some function we define. We are looking for that let's put in current position is my correct position, which will be Stall's first position, and in number equal to one. Basically, actually nothing but number of cows, right? So what I will do is what I do is obviously there's a major assumption to make sure there is no issue. This is all which is number false.
Hold on, everyone. We are having some network issues. We will be back soon. You all can post your doubts in the comment section.
That you are able to plot. Your answer will be C out, and would be time complexity would be nothing but O of so log of 1 from binary into n because n was the time because we're iterating through the entire thing once, right? In the worst case, time complexity. That's the code. Anything else? Maybe you can put this Mostly binary search goes in find what is the object and check the coordinate bases. That's a good question. Good question. So one definite way is, am I audible, Rakshit? You have some
Yes, yes, you are audible.
am I audible?
Yes, yes, you are audible, Mradul.
Okay, great. So before I go ahead, can you put this on the I'm suffering from a really slow connection, so maybe that's the issue. Right. Anyways, so what I'm trying to say is that how to avoid going into a deep
We are extremely sorry for this. We are having some network issues.
you can just any other doubts? Janvi Anap asks me, which language do you prefer to code in? I prefer C++ because of the standard template library that is had that it has, and except for that, it's also pretty fast as compared to Python and Java. So, and it's also widely supported in multiple competitive programming platforms. So that way is I prefer C++ over other language. Anything else?
I guess we are out of questions now. I think we can conclude the session now.
Oh, my voice is breaking.
Yes, your voice was breaking a bit. As of now, no. So thank you everyone for joining in. We are sorry for the network issue, and I hope this was helpful to you guys. And thank you so much, everyone. Signing off on behalf of Team Extreme Overflow.